Our next speaker is Ed Nabrotzky. Ed is the Chief Solutions Officer for Omni-ID, and he's going to be talking about using IoT technologies in manufacturing. And Ed, I'm just giving you control of the keyboard now. And
okay, hopefully you can hear me, Mark.
We can hear you, and you should be good to go. You should be able to advance the slides. Yes, you're moving the cursor. I can see it.
Okay, let's see if we can do that. Okay, thank you everyone for taking the time today. A lot of good information that Marie just shared and that a number of others will share here going forward. I'm going to try and stay at a little bit higher level to talk about applications. I'll share some things we're seeing with different customers and the market generally, and about one new paradigm we talk a lot about, which is visual tagging, which is maybe a bit unique to us. We'll touch on some of the other technologies that are not as unique, but that people have a lot of questions about, and then go through some visual tagging. So again, thank you for your time, and we'll start into it. So the key, while we're reading this and talking about it in this application, millions of containers, carts, different types of devices are moving through our manufacturing plant floors. Everyone on this call that's associated with the plant floor is familiar with the kinds of pictures you see on that slide. Racks and racks of bins, mobile carts, even trucks, trailers that are carrying materials. That material flow, along with the labor allocation, are the two central components for manufacturing, and managing them is your biggest key to success, both in terms of efficiency and also cost. Dealing with that is a kind of decades-old system of paper Kanban. Most of these containers today are routed through paper slips or cardboard cards that are put onto them to move them around through the container, through the factories. Perhaps you are using a system like that today. We'd like to talk to you a little bit about how to make that better and how to use Internet of Things technology to make the container smart and to change the paradigm completely in your plant. There's tremendous promise that we're working on with many customers around the world to bring IoT to the plant floor, specifically to attack this container issue. The biggest reason for this to happen is that the manufacturing world is changing. Back in the 70s, when paper Kanban really took off and then refined through the 80s and the 90s, getting right into Six Sigma and compressing our inventories and optimizing our WIP. It was really a lot about mass production, consistent, uniform products, made to a production forecast with demand triggers that were fairly reliable, model changes that were pretty far apart, spaced every 5 to 10 years. Paper was great for that environment, but in our current market, in the current century, the game plan's changed. We have on-demand manufacturing. We have CEOs talking about people on smart devices pressing a buy button and having a factory produce that good immediately. Not only produce the good, but let that consumer watch their part being made, watching it being delivered to their door. That kind of on-demand manufacturing, combined with the desire they have to offer more variations or more customization for customers, make it green, add a piece of trim to it. All those kinds of things have thrown a complexity into manufacturing that wasn't there 30 and 40 years ago when we built up our systems the way they are. New product introductions are coming so fast, it's not a 5-year cycle anymore. I'm sitting with manufacturers that are changing things on a yearly basis, bringing things in and cutting them in almost every few quarters, cutting in new changes. In that environment, old paper-based systems just can't keep up, and they can't bring the efficiencies that they really did during the 70s, 80s, and 90s. So the WIP gap that gets created, we can no longer see what's happening. There's no real-time visibility with paper going on. I like to think of paper as almost a ballistic missile. You launch it, you launch your goods into your factory, and you have no idea where they really are until they come out the other end. We have lots of different kinds of systems operating in factories today where they think they know what's going on because the MES is commanding the material to go somewhere. But the reality is it's tribal knowledge and lots of paper slips that are routing those goods through the different workstations. Very little traceability, very little control, and especially if you want to make changes along the way or respond to real-time demand, your factory's out of control. As a former plant manager, I know I lived this, and I understood exactly the value proposition of real-time IoT technologies and how it would help me in dealing with those complexities. So the manual counts and the inventory turns just won't work today. So talk a little bit about us quickly before we get into that solution. we're building industrial IoT solutions. We're very focused on this particular market space. We do a lot of asset tracking for visibility with our hardware products. On the left-hand side, you see all the different tags. We're the leaders in harsh environment RFID, doing things across the world in many plant floors, both in passive and active tags. Lots of different variations there. That's really for the tracking side. On the right side, you see ProView, which are our specific manufacturing solutions that we build for large capital goods manufacturing. We really focus here on the visual tagging that I'm going to introduce to you today. So how do we solve that problem of visibility of your goods on the plant floor? It's really through the ProView solution side, coupled with world-class tagging that can tag any particular asset to give you the visibility you need. I'll explain that a little bit here in the next slide. So if you're in your plant today, and many of you that are on the call are working in your operations, you really have three different ways that you're tracking goods today. A lot of manual labor, a lot of manual inventory counts, a lot of truing up of queues. This is expensive, of course, because you're allocating precious labor dollars to it, and it's less reliable because you're counting on people to do it. Lots of barcode scanning. Probably the majority of what I see now is lots of processes where you're requiring the operator to pick up a barcode scanner and scan a couple of things. In some cases, you have a fixed mount barcode scanner scanning parts as they come through a workstation. Again, also fine, but it's line of sight. It's difficult because it's easily degraded in the factory, both the label and the lens. And it causes changes to your workflow where you actually have to manually force that barcode read to happen, whether it's presenting it to a fixed reader or whether you're having a person do it. RFID, as Mark said, it's gaining traction in manufacturing, but to be honest, we're surprised at how slow it's been. RFID adoption, while there's lots of small islands of it being used, it hasn't been pervasive. The advantage of RFID, of course, is that it's reusable and hands-free. You don't have to worry about any kind of marring of the tag like you do in barcoding, and you don't have to have an operator pick up a scanner to go get it. You can have antennas permanently mounted. That's a huge advantage for your process flows. And it's versatile in that you can put it on all sorts of things. It can be tagging multiple parts. It can be on metal. It can go into high temperature. It can be buried right into a product, embedded into tools. So there's a lot of good versatility and usefulness there to RFID. But clearly, RFID hasn't solved the whole problem. It hasn't taken that market by storm, eliminating barcodes, eliminating all the manual labor and hand tracking. So there's something else that has to happen there. And maybe I can suggest what that might be. When you think about IoT manufacturing, one way to look at it is think about your cell phone. Imagine if your cell phone could only send. You could call out, but you couldn't receive anything. How useful would that be? How useful would that device be if you couldn't actually be directed? Have apps that would tell you things that you wanted to do. It would be much, much less useful. I mean, intuitively, all of us know that. We use it as a two-way communication device. I think one of the challenges with RFID is that it's been a very one-way technology. Same actually with barcode. It's not a criticism just of RFID. In both cases, you're tracking, but you're not able to actually change anything that's happening. You can report to the system and say that I see these goods, or I can see the material flowing past this place. You can create records to show what has happened, but you really can't change that flow or redirect those things. A way to think about it is with your GPS. If all you could do would be lay in a course to say that I'm going to go to this destination, and you had to follow that course no matter what else happened, a roadblock, a traffic accident, a natural disaster, your GPS wouldn't be very useful if it couldn't show you any alternative route. And yet that's the way a lot of our material flow systems are today. They're very ballistic, they have a single route, and they can't recalculate for you. So one of the reasons I think we've missed the mark as an industry is inability to do a two-way communication to make the device smart enough that it can actually respond and adapt and change, much like a GPS, recalculating and being able to get the goods to the right place at the right time, no matter what is happening on the plant floor. Okay. So we're really talking about a paradigm shift from a simple track and trace to process control. Tracking and tracing is an important element of it. You need to know where your goods are and be able to keep those records. but being able to control them and change them with the dynamic triggers that are coming from an IoT world is the really next frontier and the thing that's really important. To do that, you need something more of an enhanced system, something that can not only track, but can also send signals directly to the operator, something that can also send signals to other pieces of equipment, interacting with collaborative robots, PLCs, machines at different workstations. So Internet of Things technologies, and this is where I spend a lot of my time, sitting on various committees and meeting with management folks in different manufacturing companies. We're all questing after that ability to have smart things travel through our factories, smart containers, smart materials, that they can arrive at a workstation and talk to the robot, talk to the machinery, and yes, of course, talk to the worker, so that there is a very simple and yet seamless communication happening through IoT technology to enable the work process to happen. It's a level above RFID. It's not just track and trace. It's Internet of Things communication to enable the interaction between those different stations or their different elements of the station to produce a result. For us, that means electronic paper plus RFID as a communications media to talk to the humans and to the machinery as we arrive at those different workstations. Let me explain a little bit more of what that means in our concept of ProView. This is what we call visual tagging. An RFID tag that isn't just an RFID, whether active or passive, it also has a screen or a display that can change. This means that, yes, of course, you save on the printing costs, but it also means that dynamically at different stations you can display instructions to the human workers and tell them what to do. Through the two different radios that are built in here, both passive and active, you can also communicate with the machinery and tell them what to do. Tell them what to do to you specifically if you're a smart container. These smart tags have an e-paper display. E-paper is important because the image stays persistent without power. That means that even if the battery died, you'd at least be back to what paper is, a static medium that has displayed the last instruction that was on it. So there's no risk. You're not introducing any additional risk to your manufacturing process. You have buttons and LEDs. That allows you to have operator feedback where the operator can press a button, or you can blink an LED to do a pick to light or a pick to image, or you can do parts calls by pressing the button. You have multiple triggers, trigger points to be able to help them understand where these goods are. We integrate passive and active RFID, as we talked about, with different frequencies involved, as well as infrared, to be able to have infrared sensing as you arrive at different places. But what's important is just that there's a trigger ability to interrupt the process or to signal something or to tell you when you're at a particular place. And of course, you need the rugged case. Everyone on the call understands that our environment in manufacturing is not a typical consumer environment. These things are going to be dropped, they're going to be smashed, they're going to have to endure washdowns, and the tags are designed to be rugged that way. They're completely sealed and able to take a pretty good beating to go in. So the system starts by having a visual tag. Why? Because it needs to have the best means of communicating to people, and despite all the other trials that we've done of many different types of systems, people learn best by seeing. And a visual signpost, which is what Kanban is all about, a billboard, is still the very best way to flag a worker in your factory on what they should do next. A graphic or printed work instruction is the best. And then secondly, having RF or wireless capabilities to communicate with the machinery and the other systems in your plant means that you can go very, very quickly to deployment. You can change things without having to rewire anything in a system, and you can talk to every other device that you have on your floor. So that kind of hybrid tag is very, very important to enable the system functionality that we just discussed. How it works, your material flow goes through different islands in the factory, from your warehouse to various supermarkets, being able to distribute goods from your main warehouse on goods reception, from your warehouse management system. How do you tell that container where it's supposed to go? That replenishment forklift driver you see coming up in the top corner is where he starts using the system. He can see directly on the visual tag what he's supposed to do. Eliminate some of the pick lists that maybe you're used to running with today. Give you real-time control by the actual goods telling the worker where it should go. Tracking that as it moves forward, because we can see where it is with real-time location systems. We can see this being delivered to the supermarket and keep track of real-time inventories as required on management dashboards. But being able to pick it. Imagine a pick request coming into a smart container telling the worker, pick me. right on the container. Being able to track that it was picked and kitted and sent to the line. Having asset tracking available in the tool room. You'll be able to track different key assets or tools that are being used in production. Obviously, for a tool like a production tool going into a stamping machine, being able to auto-recognize that that tool is the right one and eliminate costly setup time, where before you had to send out a skilled trade to be able to set up the machine. Now the tool can tell the machine, I'm this tool, here's my parameters, set me up this way. And we certainly are working towards a day with our customers where they would never have to have a skilled trade come. The tool would auto-configure the machine for it and enable it to be able to stamp out parts. Different sub-assemblies in the kits. Being able to travel as a smart container and tell kitting personnel how to assemble the kit. Being able to track that kit to make sure it gets to the line just in sequence, again with the replenishment function of that. And then at main assembly, being able to display real-time work instructions. Think about what that would mean to your manufacturing. If you could eliminate the sheets of paper you might have now traveling with your goods and have them be electronic so you could show the workers what they need to do directly on the machine or directly on the line. A good example of that, we were in a very important valve building plant the other week, and one of their issues was that they would catch quality concerns at the end of the line where QA inspectors were doing pressure tests. They would recognize that perhaps a worker wasn't seating an O-ring properly. Imagine if that quality inspector could press a button on his visual tag and a new work instruction would pop up immediately at the O-ring seating workstation. A new page would be displayed telling the worker quality memorandum, make sure the O-ring is seated, show them a picture of how the O-ring should be seated, and tell them they need to press the button to confirm they did it exactly the way the picture shows. That's what we're talking about when we talk about real-time control, and paper can't do that. The ability to adjust real-time on the line for a quality issue, but even more commonly for changes in demand. If you want to change the color, if you want to change the configuration, if you want to pick stainless steel bolts instead of iron bolts, those things can happen as fast as you can send the electrons over the RF, and you can change the display instruction to your worker on the line. There's a lot of exciting things happening there as we work with work instructions with various customers. And then, of course, some of the standard asset tracking that even Marie talked about with finished goods and finding where things are in real-time location systems all come as part and parcel of the whole system. So what I'm encouraging you to think about is not so much as a product, although of course we sell a product here, but think of the paradigm shift of going away from static paper to an Internet of Things technology that's dynamic and real-time and is fully trackable as well through your plant. Think about the savings you can have. How much inventory could you reduce? How much labor would you reduce? How much savings would you have in your interactions with your Tier 1 suppliers and the paper that you eliminate off the line? How short could you make your routes? These are the kinds of questions we're working with customers to quantify and implement in the projects we've done all over the world, implementing this new visual tagging system. Let me share a few examples. I'm showing here a picking warehouse. You can see a visual tag on the edge of every shelf. In this case, it's a major seat manufacturer. You see one of our good partners standing there beside the bins as they're picking materials to make up seats for automotive construction. In this case, we're doing what's called pick the tag, where the tag can light up and the worker can just walk along the shelves hands-free and using their hands be able to pick from each shelf which part they need rather than a pick-to-light system. Now, we've had pick-to-light for a long time. Why is this better than pick-to-light? Well, pick-to-light has a tremendous setup time. Every time you have to wire up pick-to-light, you've got an electrician coming in, you've got to wire an I/O block, you've got to bring 24-volt DC power and wire along all those shelves. And then once you've got that I/O block wired up, you've got to logically associate each of those I/O points with the software that's controlling that pick-to-light. That configuration time, we see times of up to 2-3 weeks to recommission a picking line. Certainly the cost, just in terms of time, is significant when you're trying to turn variations. Remember what we said at the beginning of the webinar, that these plant managers are dealing more and more, or you're dealing more and more, with velocity. Your managers are telling you need to change over models quicker, introduce more variations quicker. The advantage here is that you can go ahead and change these tags instantly. You can reset your picking line every day. It takes you 3 minutes to reset the line, not 3 weeks. That is what the manufacturers are demanding. It's wireless, it's run on batteries, you can go ahead and scan the barcode on the part that you're about to pick, scan the barcode on the back of the tag, stick the tag up on the shelf, and you're configured. The software recognizes the tag, recognizes the location it's at, recognizes the part that's at the location, and can send the pick instructions instantly down there. So we literally can commission picking lines in minutes rather than weeks, and it makes a tremendous difference. So that's one of the application examples for pick. With pick, of course, comes a delivery and replenishment algorithm that comes along behind that. It allows us to sense and say we're out of parts, be able to come back and deliver those parts. Workers can push a button for parts calls, or we can do auto calls based on the pick algorithm. So there's a lot of efficiencies in implementing a simple wireless visual picking system. Replenishment that I was just leading into, just to go into it quickly. Again, another major customer, in this case, their name's there. So Daimler's gone, and we've written a couple of case studies about what they're doing with our replenishment system. The advantage to visual replenishment is not just that you press a button or a sensor senses that you're out of parts, but that your workers can actually see that the parts call has been placed, that the parts call is coming, that we're actually tracking the parts coming back to the line, so you don't get into a dangerous line down situation, and that you can alarm if the parts are not going to make it in time, that you can alarm and get some intervention happening before the line has to stop or the production has to be altered. Again, it's all about the simplicity of the system, and that's how IoT should be. The ability to kind of commission these tags. Imagine you have a tag on the shelf that I just showed you in the previous slide, and a tag on the line side flow rack that corresponds with the same part number. Imagine twinning those two tags. And again, this is wireless, completely wire-free, easy to set up. When a worker presses a button saying, I need more parts of this part, that call goes up through the RF and immediately is displayed on the tag in the warehouse. And that person's able to pick that part, get it sent for delivery, and sent down to the line side. That simple twinning of the tags, and that's the simplicity of just twinning tags like that, is a major innovation in making this system work, along with all the visual confirmation that you get as a worker. The ability to set up these parts quickly and be able to confirm them quickly is a major advantage in that system. So again, think about your replenishment. All of you that are on the call have replenishment functions in your factories. Think about how much easier that is with a completely wireless visual system and the kind of money you could save and the labor you could repurpose in implementing it that way. Another important one, a good example here, Detroit Diesel making engines, a customer reference on this particular application. They were using a very large build book, in their case as many dozens of pages, to specify the parameters of each individual engine. They're caught in the same issue that many manufacturers have, is that they don't make one model. They make a model with many, many customizations. In their case, they make engines for Freightliner trucks where they tune that engine and it's built specifically for the type of duty that the truck is being spec'd for. And so they do a lot of customization along the line. That build book, though, is very onerous. It takes a long time to print, costs a lot of money, and even the markups and the challenges that come with marking it up through the different inspection process are difficult to do and get lost. So putting a work instruction that's electronic allows you to have the savings of the paper, but also allows you to track the progress of each engine. Because it's a smart tag, it can tell you where that asset is in its build at any given time. Remember, one of the things that I told you at the beginning of the webinar was that our CEOs of our manufacturing companies are demanding more and more transparency into the factory process. They have to face competition where customers are buying high value-added goods. Those customers are starting to demand that they can order it and actually see it being made and be able to know exactly when it's going to be delivered to their door. This kind of transparency is going to become increasingly important in the future. I don't know how far that trend will go. We laugh sometimes when I sit in the boardrooms of these manufacturers and we look at the investment Facebook is making over virtual reality, the ability to have work tasks be very experiential with 360-degree cameras. They sometimes picture a customer being able to be in the factory, standing at the shoulder of the worker, being able to watch them do the job of building their car. Maybe we'll get to that stage, I don't know. But certainly IoT or Internet of Things is bringing the consumer much closer to the manufacturing line. And they're demanding more and more transparency to see what's happening and more customization to get it exactly as they want it, not just to buy one of millions that are coming off the line as identical twins. The other advantage here to the work instructions is, I mentioned a little bit on the earlier example of the quality, being able to adjust your quality or adjust your processes. This really plays into the scene when you have a lot of temporary workers or when you flex your workforce, and maybe some of you on the call are in that situation. Imagine you bring a temporary worker in, the training time can be heavy, and they can run into things where they're not sure what to do. Can you imagine if they could press a button here, say the second button from the left, they press that, and up would pop the instruction on how to do the work task they've been assigned that day at that workstation. Most of your workers might not use it, but it's there as a resource for them to go ahead and say, oh, that's how I'm supposed to assemble this, and go through some step-by-step tutorials or instructions to be able to go through it. Not only go through it, but confirm it, that they did it. That's a nice extra piece. Imagine if you send your technician to change a tool or to service a piece of equipment. He arrives at that workstation, and everything to do with that workstation has already been downloaded through the RF onto this little smart tag. But if he could press the third button from the left, and up would come the service instructions for that machine, how to change it out, how to reset it. Maybe you don't even need to have the technician come out. Maybe the worker at the line can press that button and do some of the basic things themselves to work it through. Having dynamic work instructions that are location specific can really impact many, many different aspects of the way your guys do their job and the amount of labor you need to allocate to get the job done. So as the graphic shows, this is really about a smart tag traveling along through a series of triggers or beacons, knowing where it is at any given time and displaying the right instructions for that particular workstation where it is. That's the basics. But the detail, when you start thinking as a process engineer of what you want to display, that's where it gets fun. And you can do so many things when you're not constrained by paper anymore. Container management is the big topic we started this webinar with. Those 500 million containers that are flowing back and forth between Tier 2s, Tier 1s, OEM suppliers, those are the real heart of this system. We use them from everything from hard appliance goods to semiconductor to medical supplies. Tracking those returnable containers and making them smart so they can tell you what state they're in, what they're filled with, what the count of what they're filled with is, what its next steps are. We have a concept of a recipe or a series of steps that it might have to go through, kind of like a GPS of how it's going to go through your plant. All these things can really powerfully impact the number of containers that you need to use and how quickly you can turn those materials, eliminating the queues and the buildup that you have in different parts of your system, eliminating the transfer time that it takes from your Tier 1s, for instance, to get the order. Just think about that in the basic scene. Today, you might send a demand trigger over to a Tier 1 and say, I need to build a batch of 200 of these particular parts, left-hand mirrors that are painted blue. That'll get printed at a printer somewhere on a sheet of paper, and someone's going to pick that up off the printer and walk it out onto the plant floor. They might have to replicate it into 2 or 3 copies and maybe tear those off or put them in mailboxes, different people, as a demand trigger to say, we need to build these 200 left-hand blue mirrors. Imagine the difference if that demand trigger went directly onto the container at the mirror station. And the worker is standing there, and the next mirror comes down the gravity-fed rack, and it says on the smart tag, fill me up with left-hand blue mirrors. And all he has to do is start filling it up with left-hand blue mirrors. No paper, nobody walked it out to him. And more than that, as soon as that command hits that smart container, that container reports back to the system and tells the OEM, call it General Motors, might say, oh, your container of left-hand blue mirrors is being filled right now. And maybe after it gets through the filling station where they put the basic parts in, maybe it goes to paint and gets painted blue. GM gets a report back saying, oh, your container is being filled with, or is being painted, right? You can see the progress of your materials continuously. Your workers don't have to look at any other piece of paper. They can be told directly by the container what they're supposed to do to it. And maybe you don't even need as many workers because the container can talk to the robot or to the PLC or to the machine at the station and say, paint me blue, fill me up. That IoT technology can flow right through your system, and if you really think about how to do that and the cost savings associated with every one of those steps, you can get really excited. Not just about the cost savings, but the increase in velocity and the accuracy of what you build. You eliminate waste and you eliminate time, so you can be more responsive and more competitive in a global manufacturing marketplace. So container management is about having reporting and control, not just power code or RFID to scan and tell you what happened, but to be able to instruct and direct the process through your facility and also all of your tiered suppliers throughout the marketplace. That reporting and control, networked in a true IoT fashion, is a game changer and will totally change the way manufacturing is going to be done over the next few decades, just as Kanban did over the past few decades. Asset tracking, of course, with passive or active RFID, is still a core part of the system. There's lots of things you have to track, whether it's people, whether it's tools, finished goods inventory. Lots of good examples of different things that we can track using those different kinds of tags. That's still, of course, on the table and integrates with the system. Not everything needs to have a visual tag or an instruction. There's plenty of things that you're tracking that really just need to be tracked and counted. And so, of course, that can be part of it, integrated in it together. And that's not at all an issue. Active RFID, I think Marie did a great job talking about that, and I won't spend a ton of time here, but you use active RFID whenever you want a longer distance or when you want to have some additional information, quite often sensor information like movement sensors, temperature sensors, magnetic latching. Active RFID does a really good job with that. There's lots of applications here, managing large yards where your distances are far too great for passive, managing people, different things you can use that for. There was a lot of discussion, even some questions in the last session about which frequency you should choose, where can I get more information about BLE. I guess the important thing that I think about often as I work with different systems and different frequencies, the longer the wavelength, or the smaller the frequency, the better it is for long distance applications. So things like large yards that you see at the bottom, shipyards or docks. We're doing a very large project now building aircraft carriers, working in different shipbuilding instances, and those docks are so long and the warehouses are so large and dispersed that active RFID makes a ton of sense. You just don't need as much infrastructure to cover the long distances when you can get 600 meters or even a kilometer of distance with the right kind of mounting and a long wavelength. So active RFID outside tends to be dominated by longer wavelength, smaller frequency protocols. We use 433 quite a lot. It really is very good for that. It also penetrates water. It gets around metal very well. So it's really good for those environments. Indoors, where you have maybe shorter distances, things like BLE and Wi-Fi are really important technologies. Of course, companies like Cisco that was mentioned earlier really push those technologies as part of their infrastructure. And so we do a lot of work with them on that as well. And it's important to be able to get that higher resolution RTLS. Outdoors with a 433, we tend to get in our location services kind of 5 to 8 meter accuracy on average. And indoors with the 2.4 or 5 gigahertz technologies, the meter to 2 meters that Marie talked about is very much attainable. So you really think about what you need, and usually on the bigger outdoor yard stuff, you don't need quite as much resolution as you do maybe inside. Okay, so just to kind of close up and talk a little bit about these final pieces. There's a lot of application examples of using different tags. Sometimes use them to store production data through the cycle. We talked about the smart tag with a visual perspective. That also happens with the passive or the active. Sometimes you want to write these codes to the tag and have the machine recognize it when it arrives. We've got lots of applications where that happens in the manufacturing plant floor. That takes away some of the worries about IT and about human intervention. Managing RTIs, I think we've talked about a lot. And finished goods, finding a car that's been parked in the lot or finding a truck trailer that's been parked out back for your yard master to find is a classic application of just straight tagging with no visual perspective on it. And again, all those are very possible, and they've come a long way since the old days. If you've tried them in the past and maybe had a failed project or you were not satisfied, you really should look at it again, because we certainly have improved the technology tremendously across the market space, not just Omni-ID, and I think many more things are possible than used to be. Okay. So to improve your process, just to summarize, you want to use RFID whenever you have a non-visual need, no need to actually communicate back. All you're doing is tracking. You certainly can do things you couldn't do before, like exposure to hot and cold. Impact, there's a lot of tougher tags now than there was in the past. These aren't just peel and stick labels. High memory tags to be able to track your process history. A lot of reuse and hands-free capabilities that RFID gives you. You should really think about those versus barcode or other other manual counts if you have that situation. But think about your framework in IoT. If you really want to think about a complete material flow management system, if you want something that's dynamic and can respond to a lot of complexity on your plant floor, a lot of different demand triggers, and certainly if you're thinking about your containers and making them smart, we would certainly love to hear from you and talk with you about that using our ProView system. With that, I'm going to wrap up since it's the top of the hour and the end of my time. Any questions?
Okay, Ed, thank you very much. Folks, if you have a question, please type it into the tool palette, and those will be queued up for me. First question is, can ProView display transponders interact with a standard EPC reader? So is it compliant with the EPC protocol?
Absolutely, and I'm glad you asked that question because it's important to note that a ProView tag is not just an active tag or a visual tag or a passive tag, it's all three. So it will be tracked through a standard passive infrastructure the same as a passive tag.
And so how do you send the visual data to, is that done over the active system?
It can also be done over the passive, but yeah, over the active gives you the long range. Over the passive, we have a template built in, or templates can be downloaded into these visual tags. The template kind of decides how you're going to render the image. And so if you write a bit code with the passive tag, just through a standard RFID write, you write to a register to the passive part of the tag. It's electrically connected with a serial bus to the active processor. And the HTML schema that's inside can fill in that template and display the image. So that's kind of how you do it through a passive. On the active, you can send bitmaps if you want to, or you can use the same HTML template format. But if you're going through passive, you just write a bit code. The bit code renders as a certain graphic, depending on what you set up in the HTML template that's been preloaded.
Okay. Why does the tag need to talk to a machine in the factory instead of using a central network to talk to the machine based on the ID in the tag?
That's a really great question. And there's a great debate, of course, over what's most efficient. There's a lot of suspicion that having large software programs that have a lot of intelligence up in the top end and trying to manage the complexity of that's less reliable than having very simple instructions. You know, the material knows what it is, knows what it's supposed to do, and having it communicate directly to the system might be a more simple or efficient way to do it. Certainly both paradigms have virtue, and actually the system doesn't depend on doing it either way. We do actually implementations both ways. But there is certainly a lot of experimentation and debate in the market right now on which way is the best, which way is simplest and easiest.
Okay. Why use readable tags instead of mobile tablets? Why couldn't somebody read an RFID tag with a reader attached to a tablet, which could have a bigger screen and could show video, can do some other things that a mobile tag couldn't do?
Yeah, that's, again, a great thing. We've done a lot of work with that on the factory floors as well. Do you want all your workers carrying tablets is the first question. The second question is, do you want to maintain a massive database and ability to look up anything as you walk around the floor scanning it? When was this material created? Where is it supposed to go? Where is it supposed to go next? The lookup and the complexity of that can be quite intense in the back-end software to make that go. What I've seen as I've worked with different plant managers, and I think back to my experience too, being able to walk through the floor on a Gemba walk and to walk up to a piece of material and see it, and see what it is, what it's supposed to be, and where it's supposed to go has a lot of virtue. It stays right with the material, and you know exactly where it is versus going and getting an intelligent device and looking it up. So I think there's a belief that there's a greater efficiency there by having it displayed directly on the goods. The other thing, there are some applications where you want that work instruction to travel with the goods and just to be ready as soon as the worker starts up. We see this a lot in some of our tier ones especially. So if you shut down at the end of a shift and all of your software shut down, your tablets have all gone into sleep mode, and you want to sit down and start up again, do you want to wait for a boot cycle? Do you want to wait for that device to all power up, to boot up, and then to resync and to pull down its data? Or do you want to be able to sit down at your workstation and that e-paper is the same as it was on Friday when you turned it off? You're showing up Monday morning. It never went into sleep mode. It's still displaying the same instruction. You pick up where you left off. There's a lot of frustration for those that have done pilots with tablets that the battery management and the boot cycles are so costly in terms of time that they prefer the paperwork instruction that stays persistent and stays right in front of you all the time.
Okay.
So those are some of the reasons.
All right, almost out of time. Last question. The tags with the screen, are they suitable for use outdoors?
Yeah, the screen, when it gets in below freezing, kind of below -5 Celsius, it will no longer change, but it stays persistent and it's not damaged. But no, you won't really be able to flip screens in frozen weather. But it certainly withstands any kind of rain or moisture and gets up to a pretty good heat temperature rating.
Okay, Ed, thanks very much. There are a couple other questions, but we'll provide those to you and you can respond to folks directly after the webinar.
Terrific. Thank you.
All right, thanks so much, Ed.